Let's now look at a class of summary statistics known as the measures of location. And the first thing we want to look at is the mean. So what is the mean? The mean is just a fancy name for the average. So now we all know how to calculate the average, right? So what you do is you add up all the values and divide it by the number of items. Suppose that we have access to the population, then we calculate the population mean, which is denoted by the Greek letter mu. We read this as mu, right? By taking the summation of xi for I going from 1 to big N divided by big N, where big N is the population size. In other words, the number of observations in the population. Okay. More often than not, we don't have access to the population, right? So we have to deal with samples. So we calculate the sample mean, which is denoted by x bar, by taking the summation of xi for I going from 1 to small n divided by small n, where small n is the sample size or the number of observation in the sample. Okay. Now, when we calculate the mean this way, this is known as the arithmetic mean. So whenever you hear the word the phrase arithmetic mean, it is essentially just the simple average. Another thing that I want to bring up is that in statistics, right, the letter big N is always used to denote the population size, and the letter small n is always used to denote the sample size. This is universal in statistics. Now, a concept which is closely related to the simple average or the mean is the weighted mean. So the weighted mean is just a measure of average where we assign a weight to each of the observations. Now, how do we calculate the weighted mean? Suppose we have sample data, right? Then the weighted mean, the sample weighted mean, which is denoted by x bar subweighted is the summation for I going from 1 to small n of omega I times xi divided by the summation of I going from 1 to n of omega I, where omega I is the weight of the ith observation. Okay. So what does this formula tell us? It tells us that for each observation, we want to compute the product of the value of that observation and the weight associated with that observation. Okay. So the product of the value and the weight. So for the first observation, we're gonna have omega 1 times x1. For the second observation, we're gonna have omega 2 times x2, right? And then for the nth observation, we're gonna have omega n times xn. Then we sum up all those products, okay? And we divide it by the sum of all the weights. So omega 1 plus omega 2 plus all the way to omega n in the denominator. Okay. So let's look at a specific example. Suppose that in one of the courses that you're taking, you have 5 grade items that determine your total grade. Okay. You have the quiz, you have the homework, you have 2 exams, so test 1, test 2, and then the final. Okay. Suppose that a student got 80 on the quiz, 89 on the homework, 79 on test 1, 84 on test 2, and then 60 on the final. That means that a simple average, right, would give you 80 plus 89 plus 79 plus 84 plus 60 divided by the number of items, which is 5, and that gets you 78.4. Now when we calculate the average this way, implicitly, we're assuming that all points are weighted equally, right, or are equally important. Okay. But we know that this is not true, right? In other words, a point you got on the quiz is not the same as a point you got on the homework, which is not the same as a point you got on the test, and so on and so forth. So that means that there's a weight associated with each of these categories. Okay, so quiz, homework, test 1, test 2, and then final, right? So you have 80 on the quiz, 89 on the homework, 79 on test 1, 84 on test 2, and 60 on the final. And let me call this x1, x2, x3, x4, and then x5. Right? And suppose I have the following weights. So let's say the quiz makes up 20% of the total grade. The homework makes up 15% of the total grade. Test 1 is worth 20%, test 2 is worth 20%, and then the final is worth 25%. So I have the weights omega 1 right here, omega 2, omega 3, omega 4, and then omega 5. Okay? So if I want to find the weighted mean for this student, what I'm going to do is I'm going to use the following expression. So weighted mean is going to be equal to 80 times 0.2 plus 89 times 0.15 plus 79 times 0.2 plus 84 times 0.2 plus 60 times 0.25. And then I want to divide that by the sum of all the weights. So in the denominator, you're going to have 0.2 plus 0.15 plus 0.2 plus 0.2 plus 0.25. Okay. So if you do the math for this problem, you're going to end up with a weighted mean of 76.95. Okay. Now, one thing I would like to note is that when you calculate the weighted mean, you want to turn all the weights into decimal numbers, right? Always should be in decimal numbers. Okay. So although in the original problem I have the weights being expressed in percentages, right? When I use those weights in the formula, I turn all of them into decimal numbers, right? Okay. So let's now talk about advantages and disadvantages of the mean. There are two main advantages of using the mean as a measure of location. First off, the mean is really easy to compute. Right? For the sample mean, for the simple mean, the only thing you have to do is you add up all the values of the observations and divide it by the number of observations. It's really straightforward. The second advantage of using the mean is that it's very intuitive. Right? We all kind of know what the average is, and we know how to make sense of it. Right? Now, the main disadvantage of using the mean as a measure of location is that it is easily influenced by extreme data points. And we will talk about this disadvantage in the next video. But I just want to bring it up here so that we can motivate the discussion in the next video. So in this video, we learn how to calculate the mean, which is the simple average, which is also known as the arithmetic mean. We learn how to calculate the weighted mean, and we discussed the advantages and disadvantages of using the mean as a measure of location.